please just put up your hand and slow me down. I know most of you are bilingual, but yeah, a fast English speaker is just about as annoying as a fast French speaker, so I can slow down. That's fine. Yeah, je ne parle pas français. Should be good. Yep. Go.
Donc, on a cet après-midi un talk en anglais, Active Directory Password Insecurity avec EvilMog. Donc, go on.
Perfect. Okay, so yeah, this is a talk on Active Directory Password Security. Let's make sure this mic actually looks right. So, on that note, it's a bit about me. I'm a chief architect over at IBM X-Force. We're a pen testing group. No one cares about that. I collect black badges. I've up to like 6 now somehow at various conferences, mostly from playing Hacker Jeopardy, which is a complete degenerate game. I'm a retired member of Team Hashcat. When I say retired, I haven't competed in the contest in the last 3 years because, quite frankly, DEF CON's too big and I have other things to do, like play Hacker Jeopardy. So, but I do specialize in writing methodologies for the Hashcat team. I'm a former sailplane pilot, and they're giving me back my medical in about 2 weeks, so I'll start flying again soon. I play with fire, oddly enough. Special effects pyrotechnician, odd little hobby. I'm a bishop of the Church of Wi-Fi. Some of you might have met Renderman. We go around doing silly things at DEF CON, not a real church. And I have won so many Hacker Jeopardy events that it's not even funny, and I probably lost Hacker Family Feud last night, so. All right, we're going to jump straight into the meat here. The fun part about Windows is the storage technique is interesting. So you take a plain text password and you UTF-16 little endian encode it, run it through MD4, and that generates 16 bytes. So when you dump a Active Directory password hash using a tool like secrets dump or whatever else, it shows you your user ID, your relative identifier, an old ancient format called the landman hash, which in most Windows these days is replaced with a static value if you set the right group policy. If you find landman in your environment, you should feel bad, but that's not what this talk's about. And then it shows the NT hash. Now this is important for the next batch of diagrams I'm going to start putting out. And by the way, feel free to take pictures if you like these slides. I will not be offended. So we're going to go through some common Windows hash types. So we got the landman hash. It's super fast. It's DES-based. Hashcat mode 3000. You see these in environment, they're probably running some ancient SCADA ICS system that nobody really likes, so like run far away. The standard NT hash, which we're going to talk a little bit about, is what you typically dump from an Active Directory controller. Little known fact, NT hashes are password equivalent. I don't need to know what the NT hash is. Say in the case of a domain controller, if it's 128-bit characters, I just have the hash, who cares? That's good enough. And that's become important later. NTLM version 1. This is a DES-based protocol, which we're going to talk extensively about here in a little bit. It's normally mode 5500, but we're going to abuse mode 14,000 DES cracking to reverse an NTLM version 1 hash to NTLM. So that's going to get fun. You'll see some Kerberos-style attacks, etc. The one thing you never want to try cracking is if you see a DCC2 hash, that is so highly iterated that even the most modern GPUs just cry on it. So you generally want to find a different technique, especially if you're a new pen tester. You'll see it in secrets dump all the time. You send me a DCC2 hash at work, I'm going to tell you go away, find something else. That's the nature of the beast. So on that note, NTLM challenge response looks like this. I send you a logon request. Your server sends me back a challenge. I send you a response. Simple, right? It gets more complicated shortly, but you know, this is generally the gist. Everyone with me here so far? Perfect. So, this is where things get complicated. Everyone here familiar with the tool called Responder? All right, so for those that don't know, Responder is a tool where I can go listen on a network and output bogus challenges as well as reply to things to try and elicit some kind of challenge response. If you have landman compatibility level set to 2 or lower, you get the lovely thing known as NTLM version 1. And the response breakdown looks like you get the account, you got blank, you got a domain name, you have a landman response, which in this case is truncated down to 16 bytes because of this lovely thing called SSP, which I'll go into a little bit later. You have an NT response, and then you have the client challenge. So these things can all be used to reverse an NTLM hash. And where that's important, I actually do some bad crayons, so don't laugh too terribly hard. But yeah, so you can see the landman response here. This is the truncated value before the 16 bytes. The section in green, as well as for some reason I did purple, because apparently I'm two, is the client challenge part. That's important. You'll see that in a second. Here's the NT response, which we'll use later on, but this is more for technical term level setting. This next one should probably be an eye chart, which I'll have fun explaining. Yes, here's the guts of NTLM version 1. Now, I want to preface this with saying this protocol is not Microsoft's fault. Some of you might be old enough to have been doing IT back in the 90s. I know I was, sadly. Back then, you couldn't have strong cryptography. It was banned. Thanks to export controls, everyone was stuck using basically a DES-based protocol as opposed to things like MD5 HMAC, which is used in NTLM version 2. So, you take a domain controller. All domain controllers in Windows have a 128-character random password. And it changes about every month or so, given 45 days, give or take, in an environment if your group policies are default. Now what you do is you NTLM encode this using UTF-16LE encoded, and then you do MD4. That's all it is. NTLM is just MD4. Shocker, but it uses a slightly different mode. Now what we're going to do is you're going to null pad that out to 21 bytes, which comes in handy a little bit later. Now you take that and you encrypt this, or you use this as a DES key specifically, and you encrypt the client challenge. So the client challenge is that section at the end of an NTLM version 1 response packet. So depending if SSP is enabled or not, there's some additional server client challenge shenanigans, but that's basically the gist. And it splits it up into 3 different DES keys. Now the final DES key, because we padded out to 21 bytes, is really only 6 bytes of challenge, which I'll show on the next slide here. Now you combine all the output of this encryption, and that becomes the NT response. I think we can abuse this. A modern GPU can crack a password, crack or a DES key, in about 16 to 30 hours using a pair of L40Ss on IBM Cloud. Ditto with AWS, your RTX 4090s. A bunch of you folks are gamers here. You all know what a video card is? Yeah, so they're getting faster. You can break this for about $30 on Vast.ai, which used to be crack.sh was $200, but I digress. This is a bit of a rant. So let's go see what this looks like with real numbers. So we've got our random hash here. That gets turned into DES keys, and you'll notice here that the third DES key is just padded out with a bunch of 010101. That's because hashcat by default sets all the parity bits to 1 when you're doing DES keying, just for a bit of a shortcut, but I digress. So what we're going to do is we're going to demo this, assuming my laptop doesn't blow up, and then we're going to talk about other techniques. But before I get into the demo, does anyone have any questions, or does this seem clear as mud for most of you folks? Clear as mud? C'est bon? Perfect. I know like a few French phrases like je ne parle pas français, parlez-vous anglais, c'est bon. That's about it. Good enough, right? All right, so we're going to talk about some other techniques that I use in hashcat before we get into the live demos. Back in the day, hashcat didn't have a word list mode. It was originally built for like 2 hash algorithms, MD5 and NTLM, and it has this concept of a left side and a right side. You couldn't take a word list, and rules didn't exist. This was 2009 era-ish. So we had to emulate word list cracking modes. So we basically would take a word list, and we run it through Expander. Now what Expander does is, it takes, say, the word Hackfest. It splits up into chunks like H, HA, HACK, etc., all the way down the line. Then also takes those iterations, and it shifts them all to the left. So it becomes, ACKH, CKHA, KHAC, right? And then what we'll do is we'll combine all these together on the left and the right side with a word list, and you can get some very interesting attack techniques. So we call this fingerprint. This attack was created by Martin Bose, aka Pure Hate, or Can't Computer Now, over at TrustedSec. And this was the only way, oddly enough, in hash cracking. And so my methodology is a lot of take excrement and put it against a vertical air displacement device blowing against a wall and see what sticks. Or for those of you who don't, that's a bit too verbose, throw crap against the wall and see what lands. Kind of like playing Battleship Infinitely. So What you do is you basically take a compile expander and you modify the size. Now, one thing we have to do here, and I apologize if this turns into an eye chart. And I think I'm on the Hackfest box. Excellent. So we go to cd opt, hashcat utils, src, and of course I can't type today. Go figure. I do live demos to make me feel alive. So, if you look at the source code for Expander, there's a line right here. By default, Expander is neutered, for lack of a better term. We have it this way because we built it back in 2009 and GPUs kind of sucked. So this is the maximum length of a word it'll process. You change the 4 to an 8, you save it, and yes, I use Nano. I'm sorry, you Emacs users. Ooh, he didn't mention Vim. Oops. You type make, and now magically the hashcat utilities work. And I'll send you some QR codes to go scan. I swear they're not phishing. But that operates that. So, cool, okay. Mirror displays. Yeah, we'll see a lot of this. I apologize. I can't computer. So, this is what I call the expander fingerprint grind. So, say you've cracked a bunch of hashes on Active Directory, and you've got a bit of a word list. Well, the hashcat pot file is the file that stores all of your passwords that you've already cracked. So you take it, you run cut-d colon. What that does is says, here's the colon separator. I'm going to move everything from the right. Now the problem is, what happens if you have a colon in your password? That messes up most password crackers. So you go -F2- to get everything past that. You then run that through Expander, because it takes standard input. You run it through sort, because you output a whole bunch of garbage that's duplicates, and then turn that into a candidate.exp. Then you go and you run hashcat. So I run hashcat.bin, mode 1000, which is Active Directory. We specify our hash file. We use attack mode 1. Now, you can set workload profiles, but for the sake of clarity, this is just being easy. Then we specify the candidate.expand that we had on the left side, do it on the right, and then you rerun this process again and again and again. Run that about 20 times, take you about an hour, and you'll crack 50% of the word list. Who knew? We have another technique called the cut B takeout. Now, thankfully, I output a little script, which I'll outline later, that had made a more advanced version of this, but this is a simplified copy. So what cut B was, you familiar with the Chinese restaurants where they all come from the same dictionary word list, like Wind Dragon, Golden Dragon, they all follow the same kind of formula? Well, this follows the same kind of thing. This is what we call, others known as password splicing. Now, the original blog that wrote this back in 2012 no longer exists, and sadly, Wayback Machine just got hacked, so we can't access it anymore. So this is my 3 a.m. half drunken from sake rewrite this morning, so I apologize. So what you do is you take a word, like, say, Hackfest. I'm going to copy out, like, the HA and all the rest of the stuff, but I'm also going to splice out words from the middle of it. So the ACK, the CK, and then numbers. And you compile this into a big left and right list. So this is very similar to Expander, but it gets different portions of the word list. And you can actually combine these two attacks. So in this case, I'm grabbing everything from the end to the right, and then everything from the right all the way to the left. You combine them together, and you create this candidate.cutB. You pipe it through A1, and magic. So again, you make a bash script, you prep your word list, you run the bash script. Reasonably simple. You run hashcat, and then the other cool part is, hashcat has these new modes called hybrid. So I have the left side from this magical word list. The right side, I can do a brute force attack. So question A, which is use all characters, question L for lowercase, question D, I can go question D, question D, question D, question D, and cycle through all the numbers for 2016, 2017, 2024, and use that to rapidly add on the years to the end of an attack technique. And so you do this for both the left and the right side, and you get far more results. Now I'm going to preface this. These are very highly inefficient techniques. I would not do this on a salted password from Unix, like salted SHA-512, that only gets you 2 million keys per second. This is designed for 600 billion keys per second on NTLM, hence why it's a highly inefficient but highly effective. There are two schools of thought in hashcat on how they operate. So my friends like Chicken Man and the other members do very targeted, very precise kind of attacks that require a lot more efficiency. I'm be honest, I'm lazy and it's garbage. ChatGPT writes half my code. So I'm going the lazy, inefficient route because ain't nobody got time for that. So you repeat this grind over and over and over again, and that's what gets you through. Another technique that's beautiful, there's a tool called Prince, probability chain, infinite, blah, 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 whatever. It's a tool that takes a word list and outputs more possible candidates. So what you do is you download RockU. Everyone knows where to find the rocku.txt. If you don't, it was a leak from, let's call it 10 years ago, that had a whole bunch of candidate passwords. Then you go to compile the Prince processor. Now, Prince processor will output the same data every time you run stuff through it. But what you can do is you can shuffle the word list before you pipe it into the Prince processor to output more randomized results. So I shuffle RockU, I pipe it into Prince processor. Then you pipe that into hashcat with your attack mode 0. And the fun part about this is you can specify 100,000 rules, randomly generated. So I don't have to go think. It's just AI does the rule for me. I turn on debug mode, which basically captures the rules, the input, and the output. What that'll do is means I can go re-abuse these later on. Put that out to an output log. So you do your cracks, wait a couple hours, go grab a cup of coffee, you know. If someone asks what you're not doing anything at work, say, oh, I'm sorry, I'm cracking hashes waiting for them to go. You know, you've got your excuse. Then when you're done that, we're going to use cut. Now, the point of this is cut-D1 means I'm going to take the initial word it caught on, and then I'm going to sort it, put it to a candidate list. Then I'm going to go cut field 3 and grab all the remaining stuff, put that on the same candidate list. Then field 2 is the rule that matched from generated rules. Now I'm going to run hashcat on the candidate list with my debug rules, and voila, we crack more passwords. And then you repeat again and again and again. This is called raking, but with the advancements of Purple Rain. So where Purple Rain comes from is Prince, you know, the great musician, and by doing this random shuffle technique, that becomes the Purple Rain with the generated rules, and raking is the capturing of the debug rules. It's an interesting technique. It's not well talked about, but it is very effective on AD internal assessments. So with that, if you want to download Prince Processor, I swear to God, this is not phishing. And if you want proof, the actual Git link is right there for you to compare, just in case you don't trust me, and I wouldn't trust me either. Now, I made a new tool I call FingerCut. Now, what FingerCut is, it's a combination of the cut B and fingerprint attack. It's in this giant pile of hashcat scripts that automates a lot of this. Because the problem is, using the traditional cut B technique, there's a lot of overlap on where you're cutting from. So I asked ChatGPT this morning how to do this more efficiently and turn it into a script. So credit ChatGPT. Or, sorry, it should be Watson because I'm IBM, but yeah, I digress. Oh yeah, if you want some hashcat rules, this is fun. This rule name is absolutely ridiculous. Oh my God, WTF, BBQ. You know what WTF stands for, you know, Whiskey Tango Foxtrot. This is a rule that I generated 14 years ago, or 12-ish, for burning in large GPU clusters. Apparently it's effective, so now I'm sharing it. Same deal with expanded cut B. I basically took a bunch of random rules, smashed them together, did some post-processing. Honestly, I was kind of drunk when I wrote this, so I don't really know how it was built. Oops, but it works. So that's that technique. If you're really in a jam on an Active Directory assessment, this is one of the rules. It'll take about 6 hours to run, but yeah, it works. Oh yeah, again, QR code, not phishing, I swear. See, the hacking's free, the report costs money. Oh yeah, so the tool I'm about to demonstrate, the NTLM version 1 multi-tool, this is a tool for reformatting NTLM hashes to go crack with hashcat, and I'm going to demo it here in about now. So on that note, in the slideshow, I love it when that part comes up, which means now we get to do the fun stuff. Don't allow. All right. Mirror displays. I swear I practiced this, but you know, computers are hard. So on that note, we're going to go type, make sure I got my IP, responder, we specify the interface of Ethernet 1, force proxy, and we sit. Now, are people here familiar with authentication coercion? Things like petit potam, the print spooler bugs. What we're going to do is we're going to use a regular user credential, and we're going to force a domain controller to authenticate to me. And it's going to do some very evil things. So, we're going to go coercer. We're going to specify my user of user1 and the super secure password of password exclamation mark, because I'm not putting a real one in front of you people. Darn hackers. We're going to specify my domain of mog, my target of 192.168.46.5, that's our domain controller, and my listener of my current local IP. I'm going to hit enter. And now we're going to hit continue, 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 and hopefully, aha, et voila, we have an NTLM-v1 hash. So what can we do with that? Well, let's find out, shall we? We're going to go to opt NTLMv1. Oh, I didn't clone that. Well, let's find out. Git clone github.com, that EvilMog jerk that's talking, NTLMv1. Oh, come on. No. v1-multi. Apparently they don't teach typing skills anymore in millennial schools, so I apologize again. Oh wait, I'm a Zennial, not my problem. Alright, NTLV1 multi, and Python 3, NTLM multi .py. One sec. Python 3, NTLMv1.py. This is more to use my Mac instead, but we paste. So, what this tool does is it breaks down what everything typically is. So in this case, it's like, yeah, here's your hash field split. The most important thing we're looking for is how to make our hash file. It's literally copy and paste. Because, quite frankly, I'm lazy. So, we copy this in. Now, because we don't have 6 hours to do some movie magic and crack a password, normally we just copy and paste this line here and it would crack for us. But I don't think you want to wait here for 36 hours. So, we're going to take the domain controller hash and convert it into des. I swear I'm not cheating. Python 3, des. That's it. Python 3, NTLM, to des.py. Text help. NTLM. Cool. So, because I like copy and paste tools, this is how I create my candidate file. So, because we're just going to demonstrate hashcat, not the fact that I have more GPUs than we all care to count. So, what you'll do is you go hashcat -m 14,000. Where was it here? 14,000.hash des.canned. And through the power of time travel, recovered. Okay, it's cool. So magically I'm the greatest hacker in the world. What does that mean for me? We're going to go DAC show. And what you'll see here is it output the first des key that we have cracked. And it's way different from the NTLM hash we pasted in earlier. You'll notice the NTLM looks a little bit different where I pasted this. Anyways, the important part is we'll take this portion number 1. We need to use hashcat utilities to convert this into back into an NTLM key. So we go /opt /hashcat utils source. What's the name of that tool now? We are looking for des key to NTLM. You paste part 1. Cool. And then we're going to do this for part 2. Or part, how do you say 2 in French? Duh. There we go, part duh. All right, that's part duh. And now we're going to grab from my magical tool, because God knows we like tools. Here it is. So we copy this. Now, the reason why we copy this is you need the landman portion If it was a straight mode 1 or a mode 0 with SSP disabled, it would output a slightly different output. So what we're going to do is /opt/hashcat. I can type today. Hashcat utils src and paste. Now on that note, it outputs the final portion. So how we get our password is dollars or NT hash equals 1, 2, and 3. Congratulations, we've just cracked 3 DES keys. I mean, obviously this would take 30, 40 hours, but good enough. So we go crack map exec, our SMB. Now the new tool is actually called netexec, but muscle memory says crack map exec, so I've got it mapped out. Yeah, so sue me, I'm not exactly accurate and up to date. 46.5 tech u DC1 $. Now the reason why I have to use quotes on this is because you put a $sign in bash and you have all the expansion stuff, things get cranky, so you always enclose in quotes -h $hash or NT hash, because apparently I can type. Oh wait, I'm on the wrong tool. My bad. We're gonna copy this into Kali. And obviously I'm gonna need to do this. That's gonna fail because NT hash doesn't exist, so we're gonna grab there. You know what? Let's just do it. Of course, the YubiKey fires off too. You see, I do this live because this is how I feel alive, so, you know, it's kind of funny for me. There, we're going to copy you. Oh, yeah. Merci. The caffeine has not kicked in, I swear. The important message for this, for those of you that are new, even experts make mistakes, even the guy who writes the tools, so don't take yourself too seriously if you make mistakes. Cool, so this cracked. Now, what can we do with that? Well, NTDS, DCS URI. All right, 1 sec. It should be DC sync, yeah. Sec. Help fgrep-i sync. What can I say? I'm being lazy here. It's all about syntax. No, I'm not doing the user. I'm going to do the entire thing. I just figured where I had my typo. Where are you? Yeah. --NTDS. That's what I thought. Did I just miss something? That's what it was, okay. Now, for those who don't know, this is what it looks like when you dump a domain controller. So what I did was I pretended to be the domain controller and told it to replicate everything to me. So if you were anyone here in a defense portion, like working in a SOC or do detection engineering rules, here's a pro tip. Get a list of your domain controllers, make a sim rule that says if you see DC sync from a DC to something that's not a real approved DC, you probably have a hacker or a pen tester in your environment. You may want to rotate. So that's the gist of this magical technique. Basically, if you've got NTLM version 1 in your environment, in particular on the domain controller policy, that machine's compromised. It's just that simple. So that gives me, I got some more time here, so we're gonna do some demonstration of what it looks like to crack a password in a live password environment. So it's supposed to be me typing away, showing off how the expander technique works. So on that note, I happen to have a hash cracking box with a word list compiled by the Sinosure Prime guys. They built a password cracking competition at a CipherCon, and they let me borrow their stuff. So opt targets. We're gonna run hashcat -M100 because this is a SHA-1, not a NTLM, so that's totally fine. Attack mode 0 on this large hash list. Go opt. Actually, first let's go demo the fingerprints. So shuff, opt, dict, word, rocku.txt. Remember this from a little bit earlier. We're going to pipe this into opt prints processor src slash. Yes, I'm lazy. I don't move my binaries out of source. You'll do it too eventually. Now we're going to pipe this into hashcat. EvilMog or opt slash hashcat 6 hashcat.bin dash m or dash m 100 dash a 0 dash g 100,000. I missed something. 1 sec. Then 100. Oh yeah, that's why. Duh. 6. And now we sit. And you wait here for a good 20, 30 minutes. And you don't have to do anything. I can sit here, grab coffee while it's hash cracking. Highly, highly effective. I mean, very inefficient, but lazy's good, right? So now, we're going to do some magic. We're going to go cut dash d dash f2 dash slash opt slash hashcat 6 hashcat.pot file. And we're going to go sort unique, make canned.lst. We're going to go opt slash, where did I put you? I believe I called mine process. Dot slash process. Actually, we'll cat this first. So I made a highly effective version we now call finger cut. And that's the thing I wrote out earlier. So I'm not going to bore you with the code, but it's a combination of expander and cut B. So we're going to type process, can.lst, hit enter. We're going to wait about 20, 30 seconds because we have time. So do. Wait, that's Jeopardy. Sorry, wrong game show. Cool, 4 seconds, not bad. So to repeat that, we're going to go slash opt slash hashcat, hashcat.bin dash m100 dash a1. So we go for the left side of canned or slash opt slash cut b slash canned.cutb slash opt slash cut b slash canned.cutb and enter. No, 1 sec. Oh, that's why, because I forgot the actual hash list. See, even experts make mistakes. I mean, experts. Does its test, blah, blah, blah. Oh, look, we cracked more hashes. Nice and magic. So this will take us a couple of seconds. I mean, more than a couple seconds. But yeah, so what you do is then you repeat this process over and over and over again. So the next thing you can do, obviously, while we're doing this, we're going to change this over to attack mode 6. Now what attack mode 6 is we're going to go specify, stupid YubiKey. I have my little YubiKey right here, so my pinky slips and types things, so oops, let's try that again, shall we? Attack mode 6. So I love doing this at ShmooCon because when you screw up, they throw little foam balls at you. And so I collect a giant stack of them, so it's actually kind of fun. So keep my pinky out of the way. We're going to specify mode, attack mode. Actually, let's go with attack there. Do. So that means all. We're going to go increment. And hopefully, we get some cracks. Woohoo! See? Cracks more. Funny how this works. And then, of course, you repeat the process with it on the other side. So it's going to keep incrementing and cracking passwords. So we've done that, blah, blah, blah. The other mode you can try is you can go to mode 7, which shifts the order of these. So I take out the question A, and I do this on the left side. Question A, question A, question A, question A. And we sit here, and we wait, because hashcat's slow, and I'm sorry. Oh, look, we're cracking more passwords. Oddly enough, with weird accents and like, oh, it must know I'm French. There's a part deux in there. That's fantastic. So then what you can do is you run the process script again. Now it's going to regenerate, rerun expander, and then we're going to run the entire process again. This is the grind. You can literally just do this all day long and not have to use your brain. This means even a robot can technically do my job. Just don't tell my boss that, who will replace me with AI. And we're going back to the canned b.cut, and again, I make that fatal mistake of not putting the hash list in, because oops. Et voila. And you just keep doing this again and again and again. So that is the gist of my chat, and I'm pretty sure I am, okay, I'm a little fast, but I now have all the time in the world for questions. So feel free to ask a Pastor Cracker anything you want about my methodologies. And get back to my mirror displays. That works good enough.